2.4. Here we go. Complex numbers. Careful. For number 6, if you put complex numbers, you're half right. Oh my gosh, it's my water bottle. For number 6.
You bought another one?
No, it was my sister's. I took it from her this morning.
Well, there you go. Older sister first. Number 6, if you put complex numbers, you're only half right. Because it showed a plus b and a minus b. They were specifically complex conjugates. Number 8 was easy. Number 9, did I give you number 9? Was not. Number 8 was easy. Number 9 was not. Can you take a quick time out? Because I know some of you have a question on number 9. What was the question to number 9? Equals.
5 plus 8, 9.
Okay. Pause. Pause. Some of you are more bigger picture people, and some of you are more really good followers. That's not a great way of putting it. Some of you like to tackle or have more of a natural problem-solving skill set, and others of you get really, really good at procedures, and you're really, really good at following them. Why am I saying that? For some of you, number 9 was super easy, and you were like, oh, no big deal. A is equal to 6 and B is equal to 5. Just by looking at it. But some of you are like, no, whenever I have equations, I have to like isolate and get things alone and resolve, and you're so used to being taught a structure, a pattern, a formulaic approach to solving that you would have actually been confused on a very easy problem. Some of you needed to have a big picture view instead of just really good problem-solving techniques. Number 9, it's not really about techniques. It's more about, do you realize there's a real piece and there's an imaginary piece on both sides, right? There's a real piece and there's an imaginary piece on both sides. What's the real piece on this side? A minus 1. What's the real piece on that side? 5. And there's an imaginary piece on this side. It's the one with the I. And there's an imaginary piece on this side. And it's the one with the I. Question, what do I need A minus 1 to be?
5.
Yeah! Oh, that's easy. A must equal, oops, well, that didn't come out quite right. A must equal 6, right? That has to produce that. So A minus 1 has to be 5, so, 6 minus 1 would give me 5. Got it. A equals 6. What does B plus 3 have to be? Got him. What about the I's? No, it's okay. The I is more like a classification, right? Isn't it like, it's the imaginary piece, it's the coefficient of the, B plus 3 is the coefficient, 8 is the coefficient, we get to set them equal to each other. Oh, sweet. So therefore, B has to equal 5. Some of you guys have gotten here different ways. I'm not totally splitting the class into 2 categories, I'm just saying there are people in here that are more just kind of like natural problem solvers. And they're like, okay, look at the problem and kind of figure it out, got it done. And there are others that are like, no, I want my structure, I want my formula, I want my process that always gets me to the right answer. You probably would have gotten messed up a little bit on number 1. But yeah, A of 6, B of 5. Number 26, you were just simplifying, right? Did you kill a seal or did you let it get out alive? Hopefully distribute that negative. Number 40, did you kill a puppy or did you properly distribute? If you properly distributed, you still had to say, oh yeah, that's right, I squared is negative 1, and then combine my terms. But whether you're adding, subtracting, multiplying, or dividing, you're supposed to end in some sort of A plus BI, A plus BI. Ooh, division is weird. Oh, silly book. You didn't have to multiply top and bottom on number 52 by negative 2i over negative 2i. What else could you have done? Yeah, why not just multiply by I? Just proving to you if you got it wrong and you thought it was because you didn't do that because you followed what I showed you yesterday, you should have been fine. Because wouldn't that have just gotten you negative 14i over 2i squared? You would have had less work, well, smaller numbers to work with. That would be negative 7i all over 2 times negative 1 is negative 2, aka, that's awkward. I reduced and left my 2. That was a negative 1. Lo siento. There we go. Positive 7i. So what do you do? Negative 2i over negative 2i, so what? Positive I over positive I. They both should end at the same answer. But that wasn't the tricky one. Wasn't the tricky one the ones with addition and subtraction in the denominator? Or the ones that needed a common denominator? Ooh, who was that common denominator guy? I gave you a good one. It was here, wasn't it? 61 to 64? 61, how'd you guys do on him? Did you rock it? Because didn't you just need a, well guys, how do we ever add fractions? Common denominators. And common denominators, don't you just multiply them by each other? That times that times that. But wait, yesterday we reviewed, if you multiply by something, what do we have to make sure it is equivalent to? Which means I have to not just multiply the bottom, but also multiply the top. Sorry, I'm preemptively striking against some of the questions I know people probably have. Then I'll see if you guys have any additional questions. But there were a lot of things that could have gone wrong on this one. You might not have seen that your denominator, if you FOIL the difference of squares, you get 1 minus I squared, and that I squared is negative 1. 1 minus negative 1 is 2. Maybe you messed up in the denominator. Maybe when you went to distribute the numerator, you forgot, yes, the 3 distributes, but what else distributes? Oh, did you kill a seal here? You would have had 2 minus 3, which is negative 1, and you would have had negative 2i minus 3i, hence negative 5i. Then to finish this puppy off, wouldn't you have had to do the butterfly effect, the heart method, distributing the division however you want to name it? Wouldn't you have to take that little half to both guys? So that was weird. We didn't do any common denominators yesterday, but we've done them before, in general. You just had to do them with complex numbers and then still simplify. And then you had your conjugate division guys here to deal with too. Sorry, I'll stop making up what questions you guys have. Is there anything else you have from 2.4 you want us to look at? Yeah.
52.
52. Anything else besides?
Wait, 53, sorry.
53. Anything else besides 53? End of 61. Okay. 53 and 61. Let's start with 53 and then the end of 61. So 53. One of those conjugate dudes. Let me get my snipping tool out. You guys walk me through because some of you guys rocked it. What do we multiply by? Yeah, 4 plus, yeah. What we do at the top, we have to do to the... To simplify, we actually have to distribute, and when you do that difference of squares, not 8... What do you get on bottom? Oh, you're doing the top. I'm sorry, I went to the bottom first. Yeah, 8 plus 10i. How about the bottom number?
16.
16. We'll get there, Minus 25i squared, and what do we do to that I squared?
You make it a negative 1.
And so 16 minus negative 25 is positive 41. Now pause. This is not a plus bi form, but it's so close. What do we do if we have dividing by 41? No, you stop now, right? What do you do? Kind of. Multiply is technically divide, but multiply by the reciprocal. But don't we have to? Here's the key word. Not multiply, but right? 8 over 41 plus 10 over 41 pi. Ah! A plus B. Good? Emma, good? Yeah. And then number, help me out, Nikki, 61?
Yes.
Just the end?
But I should look at it.
Okay. Do you see what we're doing though? Common denominators you have to multiply by each other.
Yeah, this is really not.
And you show it in between, I just said it out loud. In between would have been in the numerator 2 minus 2I minus 3 minus 3I. You can think that 3 was a negative. And there's our negative. And there's our negative 5. And then we have to make that a negative 1. And then we do. Okay. Alright, any more homework questions? Going once. Going twice. Alright. Here we go, section 2.5. You guys already have the notes written and ready to go. Let me get rid of all this extra superfluous stuff we don't really need. Go, 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 go. Aha! There we go. Let's zoom in on this first page, because this first page is not meant to be super crazy hard, except the question is awkward. Well, maybe it's not awkward to you. It's kind of awkward to me. We'll see what you guys think in a second. How many zeros do you think letter A has?
1.
Why 1? It's something that we talked about in section 2.3. Why 1?
There's only one solution.
Only one solution, so some of you guys thought ahead and actually set it equal to 0 and went. But technically I'm thinking about even before we solve. How should you know this has one solution? It's a linear, and a linear is a degree of 1, and a degree of 1 is only going to have how many factors? Just 1. I mean, he is his own, like, that's it, right? How about letter B? How many zeros? 2. How about letter C? How many zeros? 3. That's what we would hypothesize, right? I'm careful. The question is not the maximum number of zeros. It says how many. Oh, so maybe we should do what Emma was doing. I think, weren't you like starting to solve it?
Yeah.
What is this 0 for letter A?
2.
Was there 1? Yep. Let's check the other ones. So for letter B, how would we find the zeros? We're setting equal to 0, but then what do we always have to think about? Oh, subtract the 9! Please no, please no, please no. Fact, right? Whenever we're asking ourselves zeros, we should be trying to factor. We didn't need to for number 1 because it was already ready to go, but no, that needs factoring. Has anybody already factored it? What do you get? Oh, I almost put a squared, sorry. You could have also written x minus 3 squared equals 0. Wait a minute. So how many zeros are there?
Technically 1.
Oh, that's tricky. There's just
I don't
1,
think
but we
it's
thought
necessary.
2. How about letter C?
Plus 2.
You factor out the x.
GCF, good. What's left?
X squared plus 4, and then that could be changed to x plus 2, x minus 2.
Okay. Anybody who said x plus 2, x minus 2? Sorry.
Not a difference.
Wrong. Not a what?
Difference of
It's plus, not minus, which means it's not x plus 2, x minus 2. It's
Oh,
wait, solve.
it's going to be -4. You can't.
Can I square root a -4?
No.
But what homework did we just do?
Imaginary numbers.
Oh wait, so I can square root a -4. I just won't get real number. Oh. Did you guys realize what you wrote at the very beginning?
Yeah.
Fundamental theorem of algebra. Polynomials of degree n have n complex zeros, real and or imaginary. Because technically, what's the only real 0 for the third one? Just 0. That's it. It's the only real 0. Now careful, some of you would have tried to do plus or minus 2. No. It's not a difference of squares, it's a sum. So if we were to solve x squared is equal to -4 plus or minus square root because of that whole absolute value business we saw earlier this year, would lead us to what other zeros? How do we rewrite or simplify the square root of -4? 2, because root 4 is 2, but also square root of -1 needs an I. Yeah? Okay, so wait a minute. We thought 1, according to the fundamental theorem of algebra, it was 1. We thought 3, and it took us a little bit, but yeah, we got 3 if we could do real and imaginary. So what about that letter B, dude? Because I still see a 2 when there's only 1. Those of you guys that were like 2 but 1 but 1 but 2, what are you thinking again? How many factors? How many locations? But how many factors? So technically we would say multiplicity, oh that's right, that's a thing. We have 2, it's just that one spot. This one, we only have 1. I mean, those 2 aren't even going to show up on the graph. They're imaginary, right? You can't even see them. So, does this theorem technically hold? Well, okay, we've only illustrated it. We didn't prove anything. There were no mathematical proofs, no paragraphs, no pages of very complicated stuff showing why or how this is always true. But we did illustrate, like, oh yeah, first degree had 1, second degree had 2, and even if they're repeated, we say multiplicity of 2. There are 2 zeros just at one spot. And then letter C says, yeah, there were 3, just 2 were imaginary. So what do we need to keep in mind when thinking about the fundamental theorem of algebra? Just because every polynomial will have n different complex zeros, what does that not mean? That's correct. What does that not mean? It will have n zeros, but what are we not going to see? But not different. Okay, they might not be different, but how do we also account for that whole imaginary thing?
Real. But not
Real.
all are real.
Ready? How does this sound? You say not uniquely real? Because they're not all going to be real and they're not all going to be unique, meaning there could be repeats and there could be imaginaries. Another way of thinking about it is that even though we are going to have n complex zeros, we're not necessarily going to have n intersections with our x-axis, right? Zeros are x-intercepts. Oh, we should see it hit 3 times. Oh, it doesn't. Imaginary zeros will not show up as x-intercepts on the graph. It's impossible. They're imaginary. It's impossible. They're imaginary. Okay, so that's just kind of a lead-in for the entire section of 2.5, because here's the struggle. In 2.5, let's go ahead and look in our book, because some of you guys are trying to start homework or thinking about homework, or you like thinking about homework early, etc. Oh, I have the book open. No, I don't. I closed it. Okay, that's fine. In section 2.5, I want us, before we even go any further, which is weird for me, I never just show you the homework at the very beginning of a section. There's a reason for it. Here we go. Do you guys see the title? I mean, you should have written it down already, right? Title is Zeros of Polynomial Functions. Okay. Let's look at the directions in homework. You ready? Yeah.
The PDF in my homework, I forgot to do it last night because I didn't bring it home because I did it in class. So should I do it right now or do it after class?
I would probably do notes just because today's a pretty big section. But
okay, so it's okay if I turn it in after class?
yes. I mean, it's late either way, so yeah. I do, though, for everyone, just because, Nathan, that's a good question. If you do ever have to turn in homework late because you didn't get it done on time, there are 2 different types of late. I do late same day, 3/4 credit, or late any other time, half credit. So if you can get it in by midnight tonight, 3/4 credit. If not, then it's just going to be half credit whenever you turn it in.
I'll do it like right after class because I have it done. I just need the PDF.
Oh, you just didn't do. I get it.
Yeah, I just didn't.
I thought you were trying to open the PDF of the book and I got all confused. Okay,
no.
got it. Yeah, why don't you do it now? That's good. Okay, hold on. Pause. Woo! Look at the vocab. Go team. That's a fun section. Anyway, let's keep moving. Guys, what do you notice about, here we go, numbers 9 through 14? How hard are these polynomials to find zeros of? Yeah, there's like GCFs where it's like already factored and maybe I can figure, oh, that one's a little weird. Be careful, be careful. But, okay, these are kind of simpler functions. And then, don't they go to, oh, that's weird. They go to graphs. If they ask me for zeros on graphs, are they asking me for complex zeros? What kind of zeros are they asking for? The real ones, aka they're saying rational, but yeah, they're asking for the real ones. Shh, Nathaniel. I hope chapter 2 goes as well for you as chapter 1. You gotta focus. Rational zero test. Because if we're looking at graphs, guys, there's no way we're going to see the complex ones, because once again, complex ones don't show up on graphs, right? But we get to use the graphs. That's kind of nice. What's going on over here in numbers 19 through 28? Can you guys see the directions? Find what kinds of zeros? Oh, so still just the pretty ones, still just the nice ones, still just the ones that you could see on a graph. You're not supposed to be in your calculator for those. Okay, so wait, where does this whole imaginary thing come in? Oh, this one says find all. What's the difference between rational and real? You're going to have to know this in homework. What's the difference between rational and real?
Real has a negative inside. And no, just kidding.
Oh, let's do this, right? There we go. Okay, complex numbers include all reals and imaginaries. All real numbers are complex numbers, all imaginary numbers are complex numbers. So if they ask for complex zeros, they want all of them. Does that make sense? Okay, so if they say complex, they want all of them. If they say real, what are we not looking for? The square root of -1 ones, right? We're not looking for the square root of negative ones. So if the quadratic formula gets us like the square root of a negative, then we're just going to ignore them. Real says, okay, none of those imaginary ones. But underneath reals, we also have, I know it's just going to help you read the directions though, rational and irrational. What's the difference between these two guys? What do you see in rational?
Ratio.
Rational is something that can be written as a fraction. So why am I going to put 0.33333 under rational? Because it's 1/3, and so would like 7/2, and so would like 13, and so would like -5. All of those are rational. Anything that's a fraction or any decimal that can be written as a fraction. So what's irrational? Something like √2, or something like pi, or something like 0.1762. I don't even know what. It keeps going forever. Something like e, or something like √17.
So I had a pair of 5s.
So if they say rational, they're only looking for the nice ones. If they say real, they're looking for the nice ones and the ugly ones. And if they're talking about complex, looking for the real and the imaginary. Do we kind of at least get the vocab a little bit? We'll see. We'll see. So long story short, guys, how many zeros will every polynomial have? N. However, are they all real? Nope. Are they all rational? Nope. Some of them are going to be complex. So that kind of starts us off into this journey of section 2.5, trying to find zeros. Oh, I saved it again. Oh, no. Okay, that starts us off a little bit. At least a good introduction to why this is called the rational zero test. Oh, wait, this only helps us with what zeros? The rational ones. The rational ones are the fraction ones, right? Whole numbers or fractions, positives or negatives. This can only find us the nice zeros. Will this find us all of them? Nope. It's only the nice real ones. Oh. P.S. Nice real ones include fractions. Fractions aren't meant to. Fractions are better than square root of 2. So, rational zero test. This is only helping us on the nice ones. Now, I have steps, which is all well and good, but for a lot of you guys, the words for steps does no good if you don't see an example along with it. So, I'm going to go ahead and solve an example where the directions are to find all the last warning and all the cards are confiscated for the next 2 weeks. Okay, so here we go. Find the rational zeros. Find the rational zeros. So how nice is that polynomial? Long story short, guys, it's worse than section 2.3, yeah? What don't you have that you really wish you did? At GCF, yeah. And there's way more terms than we possibly want. So here's the deal. We better start thinking about, oh please, is there some sort of procedure, some sort of shortcut, some sort of method to the madness? And yeah, there is. In order to attack this problem, at least start attacking this problem, we have to think about this method of trying to find any nice zeros. Not all the zeros, but any nice ones. Let's go for the nice ones first. It's almost impossible to find the nasty ones without finding the nice ones first. So let's find the nice ones first. Okay, the nice ones first. Why am I going to go ahead and over here write something like possible zeros? Is how I'm going to start off any of these factoring problems where it's just a nasty polynomial, no hints, no clues. The book hasn't told me, hey, this is a zero. Hint, 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 use him. Why am I going to write plus or minus 1, 2, 3, and 6 over 1? Where'd all those numbers come from? Coefficients. No, because 2's not a coefficient anywhere, is it?
No. It's the ones and 3 and 6.
Plus or minus factors of who? That's the constant term, right? And then over factors of who?
The leading coefficient.
What's the leading coefficient?
1.
So what are the factors of 6? 1 and 2 and 3 and 6. What are the factors of 1?
1.
1. So who are my possible zeros?
1.
I need to test 1, 2, 3, 4, 5, 6, 7, 8 different numbers. How do I test them? Well, I'm going to ask myself, are you a zero? 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 Take a breath, take a breath. We've been working towards this all chapter. Take a breath.
So you should do the positives and the negatives?
Mm-hmm. Now pause. Now pause. Didn't we have something like finding f of a's in section 2.3 when we were doing synthetic division? And some of you guys were like, I just plugged it in. And that was valid. But then the note said that you don't just, or you don't have to just plug it in. You can also do synthetic, right? So depending on your brain, it might be safer to do synthetic than plugging in, or it might be safer to do plugging in than synthetic. Guess which one's shorter? Synthetic, for every single one we have to do a box and a line and coefficients. I don't think synthetic's faster, but it is safer.
Except for the ones.
Exactly. Some of you might do a mix of both. Some of you might just plug in. Some of you, because we just need to find zeros. We need to find all of them? Well, maybe we have to find all of them this way. Or maybe once we find one, our life gets easier. Let's just aim for finding one. We have 8 different numbers to try. Nathan, why'd you say except maybe one as far as like synthetic being safer?
Well, because it's just one and that's really easy to plug in.
For a lot of you, one's easy to plug in. That's exactly where I start every single time. So if you plug in 1, we have 1, and any power is 1. 1 minus 1, 0. Plus 1, minus 3, negative 2. Minus 6, not 0. If you figure out he's not 0 and you've done your math correctly, okay, fine. That took like 2 seconds and he's not 1. Now you have only 7 to try. then 2, and then 3, and then no. How many possible nice zeros could there be? Up to 4. But why am I putting up to 4 when a second ago I would have said definitely 4? What kind of zeros are the only ones I'm looking for? Okay, that's only one type of zero. So okay, well, maybe up to 4, maybe just 1 or 2 or 3. All right, now we have an option. We could say we like positive numbers better if you're plugging in, and you could go plug it in. Or you could say I still like the ones and I think I can handle the negative if you like plugging in. I'm thinking most of us could probably plug in at least one more and still be okay. But what do you guys like better? The 1 with a negative or the 2? 1. Okay. You're going to be careful though, yeah? So, a negative to the 4th, what do we have? Positive. A negative cubed. But it's a minus a negative, so 1 plus 1 is 2. Good? Okay. Plus 1, because that's always positive, right? 3 minus negative 3.
So plus 2.
6. I think we found one. Now, how do we make sure that we were safe or that we're good? All right, let's do synthetic. Because some of you are like, no, my brain doesn't do mental math. Okay, throw negative 1 in the box. Now, if I'm throwing negative 1 in the box, there is this little factor out there somewhere in the universe of x plus 1, but that's not the point. We're trying to see, is this a 0? So we're plugging the 0 into the box, not the factor, the 0.
1.
Now we need coefficients, yeah? What do we got?
1.
We got 1?
Negative 1, 1, negative 3, negative 6.
Okay, if we do synthetic, double check my math, it was a little rough yesterday. Were we right with our plugging? Yes. Now if you plug in and find a 0, you could be like, whew, I got this. You could have plugged in all of them and seen which ones are zeros and which ones are not. But can we at least admit plugging in is going to get harder as we go? True? You're raising them to the 4th powers, 3rd powers, 2nd powers. Some of you are awesome at it. Okay, mental math, go for it. But others of you are like, P.S. Calculator would not be allowed on this question. Can anybody tell me why? Why wouldn't you just graph it and find the zeros? Bonus.
Scientific calculator.
You don't need, do synthetic. Okay, so, coming back.
Pause.
Pause! No, but it's not though! Because if any of you are like, I should just plug them all in, you're wasting time, because what happens when you do synthetic? A 4th degree is now just a 4th degree polynomial by 1 division has become a what?
3 degree.
A 3rd degree. And if we could find just one more, what would he become?
A 2nd degree.
And a quadratic, we know how to factor. Whoo! And we'd be done.
Wow.
And it saves time. Even my ones that are like, I want to plug in all 8. Please don't. Oh, hold on. We found one. He's good. Every now and then, actually, this could be a repeated 0, so maybe we could go again with negative 1. We could go back to the very beginning, but if you plug in negative 1, we just know he's 0. Wait, go back to the very beginning. Do we need to go back to the very beginning? Can't we just use what we have? If you want, we could technically just write this guy out and say, well, hold on, this is what's left. It's the exact same as the beginning, just x can't equal 1. There's a factor that's been taken out. We don't technically have to go back. We can actually just keep moving forwards. So let's keep testing. We could plug in negative 1, but just a hint, it's not going to be 0. Let's keep going. We could plug in 2, but some of you were like, well, I like the synthetic thing. I don't like plugging in. Okay, my people that like plugging in, can you plug in 2 and see if he works or not? My people that don't like plugging in, oh well, let me try synthetic again.
Which number?
Wait a minute. She's doing a synthetic on top of a synthetic. Is that a thing?
Yep.
Can be. Let's see. Bring down the 1, and that's a 2, and that's a 0, and that's a 0, and that's a 3, and that's a 6, and oh!
Wow.
Plugging in people, did you figure out it was 0?
Yeah.
If it wasn't 0, well then maybe we shouldn't have done synthetic to it, but it was 0, which is nice because now Emma and I were bouncing back and forth. We've gotten a quadratic.
X squared plus 3.
So what does that mean?
Oh, oh no.
Can't we just think about x squared plus 3 and say, hey, x squared plus 3, what are your zero?
Oh.
Does he have any rational zeros, any nice zeros, any nice, pretty real zeros?
No.
Why not?
X
That's a square root of a negative. Square root of a negative is imaginary. So do I stop? Yes, you stop. Because the 1, the 2, and the 3, 4 zeros are all right here. We don't even have to worry about anybody else because we have all 4 and 2 of them are imaginary. So what are the only 2 zeros? The only 2 rational zeros are negative 1 and 2. Now what if the question was a little different and said find all the zeros or all the complex zeros?
Then we would find the imaginary.
We would have kept going, exactly. We would have said x is equal to plus or minus square root of 3i.
Yeah.
But those aren't rational. So we don't include them this time. But if they wanted all the zeros, 1, 2, 3, and 4, haha, got them all. And if they want all the factors, different question, but if they wanted all the zeros or all the complex zeros, we would have gotten those ones and these ones. If they asked for instead all the factors, we would have taken what we learned and said, okay, well, negative 1 comes from this guy, 2 comes from that guy, and then we had that guy. That would be all the, well, actually, let's be snazzy. This is all the, well, there's a really weird way of putting it. The irreducible
Complex.
under rational numbers. AKA there's nothing else besides rational numbers in our factors. But we could actually answer yet another question. And we could say irreducible under basically go all the way and all the way, which is really weird. Would look a little different. You'd have x plus 1, x minus 2, x plus square root of 3i, x minus square root of 3i. Oh dear. Can you guys tell that based on the directions we might be putting different answers down? But do you notice that these directions, those directions, these directions, and the rational directions all kind of come back to the same process? What are we doing? Well, we're looking at a polynomial, very possibly an ugly polynomial. Now remember, homework doesn't start there. Homework, okay, well, it kind of ends there, right? There's a lot of equations on this page. Don't worry, not all of them are as bad as others. But the first page of homework is like vocab and some easy ones and some graphs. Some of you might be like, oh no, but this page is horrible and it's terrifying and it's... But some of them, they actually give you hints like, oh hey, we'll tell you one. Use it to go find other ones. Now they might be nasty, complex ones, but still a hint. Oh hey, those ones have hints too. They tell us where to start. Maybe we can do long division and figure out what's left. Okay, there are some hints in homework because they realize these get long. But we start with, if they just give us a polynomial and say go, we're like, okay, we'll go find the possibles. And from the possibles, guys, there's infinitely many zeros out there unless we narrow it down. And then from our narrowed down list, we go for it. Now, as class is ending today, don't worry, we have more examples tomorrow. This homework is not due until Friday. For those of you that started freaking out a little bit. Monday.
Oh, Lord.
I know, I forgot today is Thursday. Hold on.
Homework is due Monday?
Yes, it's due Monday. Okay, just make sure we know how to do the possible zeros. I know I have a question out there. We're going to do more examples tomorrow. Can we just make sure you know how to figure out the possible ones?
1, 3, 2, 1.
1, 3.
1, 2.
So do you guys realize that the possible ones we need to test are
1,
1,
3.
1 half.
1, negative 1.
f of 1, f of negative 1, f
F of
of
3.
1 half, f of negative 1 half, f of 3,
F of negative 3.
F
F
of
of
1 third.
3 over 2.
Do you see how I'm getting these numbers?
Yeah.
I have to think of every possible combination.
Which can get long.
Now, pause. Some of you were like, I don't mind plugging in. My brain's a calculator. Okay, have fun. The rest of you, I would go synthetic. But don't start here. Start there. Because what if 2 plus 3 is 5 minus 8 is negative 3 plus 3 is 0? Ha! That's true. What can I do with that? Why am I going synthetic?
Because then it's smaller.
Break it down in quadratics. We have other ways of dealing with. Bye, guys. Woo! Outside rest your brain if it's overwhelming. Anyone whose question I didn't answer, come find me.